When we first started talking about linear regression, we pointed out that 4 scatter diagrams that describe a linear association. The linear regression line goes through the graph of averages. The graph of averages you get by taking all the points, 4, some x value 25, and averaging them. If this were a linear association, all those averages would fall right on this line. But clearly, since it's not a linear association, they won't. Like the average residual is down here, and that means the average point for maybe 20 is going to be down below the line. And for 25 or 28, it looks like it's above the line. So we can't draw a line through the graph of averages. But we have so much data that we could draw the graph of averages directly. So here's what we're going to do. We're going to take all the examples in the control group. We're going to write a function that predicts midterm 2 based on midterm 1 just by grabbing all the examples with that midterm 1 score and averaging their midterm 2 score. And then we can ask, what's a predicted midterm 2 score if the midterm 1 score is 20? Well, how about 15.6? And if they got a 25, then we'll assume they got like a 25 on midterm 2. And how about if they got a 40, the perfect score on midterm 1, then they're probably going to get around a 45.9 on midterm 2. And in fact, we could do this for every midterm 1 score. So this is for each midterm 1 score, the graph of averages, the average midterm 2 score for each midterm 1 score. And we can see that it's not really a line. It's sort of linear here, but then it's linear with a different slope here. It also bounces around. We don't have enough data in order to get a really clean graph of averages. Instead, there's some noise in there, some variation just due to the fact that we only have a certain number of students in the course. One way to account for that in the graph of averages is to use a width around the x value and average all of the y values, not just for that x, but for the surrounding x's as well. So instead of just taking points where the midterm 1 value is exactly some number, exactly 40, we could say that we want all of the points where the x value is between the midterm score minus 2 and the midterm score plus 2. Now the predicted value changes just a little bit because it's averaging in people who got 38 or 39 on midterm 1 instead of just 40. And so we get different values. And if we draw the graph of averages where we've included the neighbors as well, then we see a much smoother curve. It's not a line. The slope is lower here. It's higher here. And then it's quite a bit lower down here. This curve describes the relationship between midterm 1 score and midterm 2 score more accurately than just drawing a line, because the association between these two scores does not appear to be linear at all. So we've found a way to perform regression, not linear regression, but some kind of regression to find a curve, and we can use that in order to predict for any midterm 1 score what midterm 2 score we would expect on average for students in the control group. I claim that's useful for answering our original question. Is there an association between being mentored and improving on your exams? How do you do that step? Think about it, and we'll continue in the next video.